So today we're going into part 3 of the stream for building Hawaii, which I'm really excited for because it's been a while since I've worked on it, since last Thursday, I think, Tuesday. And I've been having lots of ideas that I want to try out today. And I'm really wondering if it will work out. So let's just get started with it and see how that goes. I'll do a recap of where we were, and we'll explain what I want to do in this stream as well. All right. So, as you all know, we're building this project which should take a OpenAPI schema, Swagger, such as Swagger API, which is, I think, a subset of the entirety of OpenAPI, where we are going to generate F# clients from it. And the idea is that we generate F# clients both for Fable and F#. F# being F# on .NET, because if you want to generate Fable specific clients, you will have to generate Fable specific code, which things that work with Fable. For example, if you generate a F# client and you say, well, the client has HTTP client as input, such as this class, it doesn't work with Fable, right? Because Fable does not understand this class. We could also add support for this in Fable, but because this class uses a lot of .NET classes, a lot of task TPL library, TPL types, then it won't work. In which case we use something else. All right, so as always, I'll be checking out the chat every now and then to see if you have questions. If there's something you're wondering about, just let me know. I'm right here. All right, so last time what we generated, well, I'll just run the thing and see how far we were. So .NET run. What we're building here is for now just a simple console application, but I plan on making this into a CLI tool, which you can install on your on your machine with .NET Tool install, right? And so far so good. We're able to take the schema and generate those types from it. Now I'll take the schema and look at it so that we can see left and right what we're missing and see how far we can go. So this is the schema. This is in JSON. I need a JSON viewer. Let's copy this over here and look at it. So the first thing we're looking at is the definitions, and these are like global types, right? Definitions such as pet, and pet has properties, such as things like those. And last time we managed to create those types into records, such as here. And we did something really cool, I think, which is to take an enum which had no type, and we created a specific enum type out of it. So here we have status of type optional pet status, which we generated here as a discriminated union in F#, which was really cool. So the enums generation worked nicely, but we are missing quite some stuff from these definitions still, which is referencing other types from the properties. So here, category of a pet references a category from the definitions, right? But what we generate in a pet is a string, because everything, when we don't know the implementation of this create F# type, this should actually be create a record field type. So let's just change that real quick, because it's not just F# type, it's a field. It's a field of a record. So let's do this right, and let's change it here as well. Okay. So yeah, because each property in the properties, for each property in the properties, we create a field out of it. So that looks good for now. But instead of an option, we want to be able to reference the actual category. In this case, it's an optional category for the pet. So this is something I want to do today, which be able to reference those things and maybe get into the paths in here and get into operations such as this one, add pet or update pet, these kind of things. So I want to get into those as well, but it will take a while because we're far yet from done. There's a problem. If you have been following along, there's a problem in here that was kind of bugging me for a while. We have these functions, so we start off by saying, well, we create a record from each definition, right? So here we start off by saying the global types will be for each schema, we create a record. And here before that, we generate the enum types and we yield them just before the records, which is what you see in the generated code below. And in create record from schema, we also call create field. This looks okay, but the knowledge between the functions is kind of scattered. And what I mean by this is that these functions use implicit knowledge about how other fields are generated. An example for this is inside of the enums. So here I have a function that finds the enums from the OpenAPI schema, right? And it finds them and generates them based on this name. So the name of the enum will be the name of the object that contains the enum plus the capitalized property name. And then I use the same method when I'm matching the enum fields from the record in here. So when I have so here when we're creating the field type and I'm looking at the enum schema, I use the same definition where I take the record name, which is kind of the parent type. I should call it record name there as well. And we capitalize the property to get the same definitions, where we have pet status as the type here above, and the referenced type also has the same name in here. So this is what I mean by scattered definitions, and I would like to solve that. I'll try to solve that and see how far I go. So yeah, this was a recap, a little bit of what I'm trying to do today. Let's hope I can fix those. All right. Let's take a sip. Okay, first things first, let's fix the category referencing an option, because we want to know whether it's referencing a type. And for that, I'll just start debugging the code, because I want to know how to reference those things. I want to look at the OpenAPI document and see what things it contains. So debug default project. I want to inspect it using the debugger so that I know how a reference type looks like in the document. And the breakpoint did not match anything here. Well, okay. Maybe because I put it on a function definition. Okay, I'll just put it here. The F# debugger is not always consistent, but it's definitely workable. Yes, there you go. And I want to look at the OpenAPI document. And then from components, schemas, which is what we're looking for here. So we take the schemas from the components, and where the schemas. And I want to look how a category is referenced from the pet, because the pet has properties, these properties, and these properties, such as the category, will be referencing, so the value will be an OpenAPI schema. And it should tell me that it is referencing something. Let's look for it. See, these are all like the validation things. I don't think we can do anything about them in the client side, but let's see. Oh, so it has properties. Okay, that's interesting, because I'm looking at the category and it has properties. Hey, it has a reference. That's cool. Okay, it has two properties of an ID and a name. Oh, so it actually... okay, this is interesting, because these are the properties of the referenced schema, the referenced type, which is the category here. Category has an ID and a string. I won't restart right now. You can have an ID and a name, which is the reference type. And here, these properties are resolved, which is kind of cool. So I won't look at those because it has a reference, and the ID of that reference is category. So this is really cool. It already does referencing, and it resolves the properties of the reference type. So that's cool. I won't have to look into it all too much. All right, so I'll just use the reference if it's not null, and I will take the name from it. All right, let's try that. So when we're creating the field, we say if it's anything, when the property schema, when not is null, property schema dot reference, which means I'm working with a reference type. Which means I can use that reference. I'm assuming reference type will be null for anything else. I won't usually assume that if I'm not working with an C# API, but we are working with a C# API, in which case I'll just do this just to be sure. So the reference will be an ID. So it will be property schema reference ID, identifier of the reusable component of one particular. Okay, yeah. So it will be syntactic type create one from the ID. Hey, that looks about right. Let's give it a try. Hey, category is an option of category, which is what we have above here, which is great because we already defined category and we just reference it here. Same here, the tags are an optional list of tags. So the rest looks like it's working properly, and that looks pretty cool actually. So that's nice. Okay, next up is, yeah, so I think we have the types here quite nicely, but because we're working with a simplistic schema, it's not very representative of how far we are in the full implementation. Because I need to look also at more types in here, for example, numeric types, and choose whether they should be float or decimals. Let's look at the specs to see how they do it. So OpenAPI specs 3 numbers, the specification, data types. Okay, number. So it can be a float and a double, and number can be just any number. Integer can also be just any integer if format is not there. So can we just default to int 32 when the format is not int 64? I think that makes more sense. Okay, so that's for the integers. Let's go number when the format is double. It's a bit funny because a float in F# is still double. So number when float, a floating point number. Okay, so this is floating point numbers, which I think are float 32. Okay, let's just say when it's double, we go syn type double. Okay, this is a bit unfortunate because I sent a PR to FSAST to add the missing types, but there is the PR was merged really nice, but we still have no NuGet, new NuGet. So I'll just have to create them here. Double. So when number is double, then there's that. And otherwise I create the float 32, which is what this floating number is. Let's see, so let me do it the other way around. The default will be a double for any number, but when the format is float, then we create the float 32. Syn type create float 32. 32 is an F# type, right? Just let me make sure. .NET FSI let x is float 32 of some double. Yeah, that works. It's just float 32. Okay, cool. Did I just close the terminal? Okay, there you go. So when this is integer, then we do that. This number. Okay, that looks good considering numbers and the integers. So we did well on this part. Something I want to check is actually the Unix time. It should be somewhere here. Unix. It's not part of Swagger, but it should be part of the OpenAPI definition. Is it here? Unix. Data types, string, datetime, full date. Hey, this is funny. You can have a string a byte string. That's kind of cool. So byte is different than binary. Okay, we can do that. So string of format byte will be a byte array. String when property schema format is bytes, then we get characters, which means we have to create a byte array. Syntype array, rank and element type and range. We don't have a rank. Rank will be... The rank is the dimension, right? I think the rank is the dimension. I just forgot my linear algebra course, so I don't know, let's just go rank 1 and syntype will be a byte array, so syntype will be bytes. And the range is actually not all that important. Okay. Let me just check real quick. Linear alg rank of a matrix. Maximum number of linearly. No, I'm mixing things up. And I'm getting the Dutch translations of what I want. Independent. So if linearly independent vectors equal to the number of non-zero rows in its echelon matrix. No, rank is different than dimension. Anyways, I just want a single dimensional array and not like a matrix of bytes. It will be fun to test with these things because I think I will need to read the schema from a local file instead of an external schema, so that I can change it and see how the program reacts to it. But for now, I think this looks good. So integer, we get long. UUID will be a GUID. That's great. I could have probably just said byte array, but I'm not sure if Phantomas wants to format that into backticks and make a specialized type out of it. So string with format is this. I think I read somewhere that you also can have a date time with a Unix timestamp as a number in OpenAPI. So let's just go OpenAPI specs. It brings me to Swagger. I don't want Swagger itself. Oh, I think this is what I'm looking for. I'm looking at the specification itself. You should know that you're looking in the right specifications if you end up in a file that looks like it was written from 1990. List of specifications, examples. Where is it? You know how our RFCs are written, you know? Like in unformatted text. Well, here is the README, which is kind of nice. So I'm just going to look for Unix time. Timestamp. Oh well. epoch maybe. I'm pretty sure. Okay, I don't want to edit that. Epoch deep object. Well, nope, that's not it. Data types. Yeah, there's not much about them. Okay, because there are, I think, a superset of this draft, so it means everything included in this draft. Yes, this is what I'm talking about, this kind of document. Why are RFCs written like this? Which means I can find Unix here. Nope, too bad. JSON document, range values, keywords, non-instances. Mathematical integers. Okay, you know what? I will look for it when I encounter it. For now, it's fine. It's totally fine. Yeah, I found something else when you're creating a type, because I've been looking into a couple of OpenAPI schemas. Sometimes the key is not always here when we're generating the type. Where is it? Yeah, the schema. The key is not always the name of the object. So I think here we have to check for the title. Let's see, schema. Does schema has title? Value dot title. So title can be follow JSON schema definition, short text providing information about the data. Sometimes the title is the name of the type, but I'm not sure if we should keep using the key. So if this, okay, let me just create it here in a variable or a binding, a constant, a value, whatever you want to call it. So type name will be if string is null or white space, is null or empty, I think. It's null or empty. Schema value. Then just use the key, otherwise use the title. And that will be the type name. So there's that as well. Okay, .NET run, see how far we are. Okay, what I want to do is make sure I'm able to read the document from a local file, so not just here. Okay, the generated code still look good. Okay, let me go to a familiar code and grab a function or two. Source. Utilities is what I want because I want to resolve a file. String or none. Okay, this is what I want. Okay, resolve file. I'll create the schema here, so it will be schema pet store JSON, and we'll take this, put it in here, and now we can make changes to it and see how it reacts. So I think this is better than having to, well, it's not You can easily find stuff as with this UI, but that's alright. So I want to look into this file. The schema will be schema path. Let schema path is pet store.json. Resolve the file, and the schema will be I think I'm giving it a response get stream from the schema. It wants a stream. Let's give it a stream. So schema get schema will be a function if file exists. Schema path, then make a file stream. Then system IO open file reader, file stream, and what does it want? It wants a bunch of stuff. Okay, it wants the path, we got that. And what kind of file mode? Just open. Else if schema path starts with HTTP, then we will just use this instead. So that's how we get a stream both ways. Of course, new. Else we need something else. Memory stream. Memory stream. Okay. Client is here. Schema path. I should downcast it here. Is this called a downcast or an upcast? I don't know. I always mix them both. Alright, anyways, now we have something called get schema. It should be based on a schema path, which is a string. Otherwise, fail with could not create a stream from the input path. Schema path. Okay. That looks okay. So get schema will be here. Schema will be a get schema from the schema path. And let's hope that works. It's no longer a response, it's just a schema. Okay, that worked like a charm. That worked nicely, but now what happens if I use this schema instead? Let's see. Where is it? Get schema from here. Okay, so far so good. Go back to creating a nicer schema here. I could just say resolve file from pet store JSON, and that should be alright. And then I won't need to use this hard-coded thing, because you can imagine this will be coming from the configuration. Okay, now I could test more things. So these properties, let's look at, these are the paths, of course. I don't care about the paths. I care not about security now. Okay, API definition category. Let's add more things to the pet. For example, we could add a byte array. So let's say thumbnail will be a type string, and the string has a format of byte. And now we should get a byte array on the generated pet type. So far so good. I think I'm just gonna leave this open here. Hey, thumbnail is a byte array. Cool. That is really cool. All right. What else can we play with? Photo URLs XML wrapped is true. Not sure what that means, but okay. Here we have the enum we talked about. All these integers, ship date. Yeah, it looks good. Okay, so the next one I want to solve is something that has to do with the paths. Because when we're working with the paths, we have some time that... yeah, let's look at this one. Pet find by status, which has a get. It has a get method, and one of the parameters is a status. And the type of this parameter is this enum. So ideally, we would want to know how this type here, pet status, can be an input to this path, right? So yeah, it's actually the same type, just not sure how to, so the default is available, okay. Yeah, there should be some way of kind of figuring out how to say, well, this enum is actually the same one as this one. And when it's this enum, and we use it as input in the query string parameter, so you can imagine that this function is called by this path, and then it says, okay, /pet /find by status, and then underscore, question mark, status equals, and then that status where it can be available, pending, or sold. So when we are working with this enum, we have to be able to just serialize it into the string available, pending, and sold without having to work through JSON, right? These properties are made so that they're used in JSON, but in case we are using them in the query string parameters, then it's not, then we don't want JSON in there, we want just the value. So aside from figuring out how to map those things back to this enum, aside from that, then I will just see how it goes from here. Actually, we could ignore this and say it just accepts a string, but it still be able to say that these strings can come from pet status. So what I want to do is have a member here, a function of an instance for pet status that is named, for example, serialize or format, and format will take those cases and returns this string in runtime, right? So this is what I want to do. For this generated enum, I want to have a new member called, so if you had this thing here, it will have with member this dot serialize or format. I think format makes more sense. So format, I'm not sure if it should be a function, but basically it will match this with available and returns this string and the other ones as well, pending, pending, sold will be sold, and then you will be able to use it like this. So pet status available format, which is a string. I think a function makes more sense. It's like a computed property. So let status will be this thing, right? So you could use that as input. You could use that as input for this function, because you could imagine the generated function will be called find pets by status, and then as input you will say this thing, so that it stays type safe and that it could work without reflection in runtime, because these compiled names are made for reflection, both when serializing and when using. But let's just try to generate this type, this member here. Okay, I'll just leave this here for a second, because when we generate an enum, where's the enum? Yeah, here we have the create enum type. We generate it and we say create simple type, and it has something called members, the third parameter here, which is optional, which is of type sin member definitions, which I think is a list of sin member defin. So let me try to do that. So members will be an empty list, and let's just let F# figure out what that should be. It's an A list. I don't know why I get indentation warnings. Okay, it still does not figure. Okay, it has figured it out, where it's a list of A, where A is sin member defin. So this is a sin member defin list. Okay, and we can create those, hopefully, using a create function. Okay. We don't want an interface, but we do want a member. And it takes a sin binding record. and returns that member. Let's say SYN binding record. Hey, that's not what I wanted. Yeah, it wants a member. Yeah, I definitely want a member, so a member definition will be SN binding. Okay. Member, and the member will be this SYN binding. Let's see what that does. Okay, what's a binding? Oh boy. Accessibility, the kind is inline, the documentation, the expression. Is mutable, the attributes, the docs. Oh boy, okay. We have to provide all these things. I'll look at the FSAST to see if they have examples. I think they do. So FSAST. I think we had a sample with create FST. Yeah, here we have a record and it has a member. So we start off with null, which I think is a member that has default things. Okay, let's do this. It's a member null, and the pattern of the member will be this. Points, and for now it's just a constant 3, so the pattern and the constant along with ident. Okay, let's try to see what that does to our enums. Hey, member this dot points equals 3. Let's see, pattern is SYN pat record. Create a string, and I think create long ident. It takes args, where the args here is empty, but I don't want empty. I want to take unit as input, such as this one, right? It's probably not needed because it can be just a computed property, but I think functions are nicer. So let's say the arguments is just a unit. Can I create SYN pat record, create type, create tuple, create parent. Okay, it's a parent of another patron, which is nothing, right? Okay, these types are a bit weird, right? Let's say let's just use a constant of type unit, if that exists. Come on. Okay, that's nicer. So it takes a constant of this record. Okay. Let unit const will be something that has let's just see what it has. It has a range and a const. The const, the range will be the 0 range, right? Range 0. No one cares about the range. I think Fantomas makes sure that the ranges are correct. So the const will be a sin const of units. Okay, and we use that in here. Okay, that's how you create a constant unit. Okay, so far so good. And this will create a function that returns a constant of 3. I said I'm learning a lot from the Elmer's book and February emoting ducks. Hi there, glad to hear that. It's always good to hear to know that someone is still reading them. I haven't heard a lot about the Elmer's book recently, to be honest. Maybe people are just happy with it, but really happy to hear that you're using it, that it's useful for you. All right, yeah, we have our member this dot points and equals 3. We're getting somewhere. Now let's tackle the expression, because now it's just a constant expression, and instead of a constant expression we want to have this pattern match expression instead. Okay, so let's we're actually getting there. So the function will be called format, and the expression will be a match expression. Dot match, and match will take the clauses What's a debug point for binding? What the hell is this? Okay. Debug point for binding. No debug point. Okay, I'll just go with this. It takes a range, so range 0. The expression itself, the match expression itself will be this, like the current instance of the generated enum. So it will, the match expression is what is expected to be in this part, right? So this will be just this or self or whatever you put in this string, right? So this is the match statement. The expression will be sin expression some identifier, and that identifier will be this. There should be some better way to do this. It's and then no match statements at all. What else? These are the clauses, and then the range will be range 0. What did I miss? This constructor is applied to arguments, but it expects 4. Where I did give you 4. Yeah, that's what you mean. Did I have one too much? Yeah. Okay, so now I can generate code that won't compile because it has no match clauses. It probably will just fail, right, when formatting the code. Yeah, as expected. It will just fail because there are no match statements in here. No clauses. So let's implement those clauses. Let match clauses equals an empty list, which I'll put here, and the clauses will take a sin match clause. Okay. It takes a pattern, it takes a when expression, optional when expression, and the result expression. So the sin-pat expression will be the name of the union case, and the result expression will be then the string constant that gets out of it. Okay. Which means that for each value in values, we create a match clause. Where the matched value is a sin pattern of identifier long ident sin pattern long ident. Oh my god, so many things. Long ident with dots needs so many things. Okay. Long ident with dots. Create, which will take, and then range 0. Okay, this is just a pattern. I want to take here. But it expects range is this. Pat is this. Aren't the other ones optional though? Yeah, everything else is optional. So why is it type or declarations, arguments? Oh, the arguments are not optional. Okay. Accessibility is also optional. Okay, this is a bit complicated for a single match statement, isn't it? Okay, let's just do it. So long ident is this thing. Sin pattern, maybe it has a nicer create function. Can I create a constant instead? Maybe that's easier. So it's a sin const from an identifier, no? Okay. Because I basically want to take the value, which is capitalized, and put it into the sin pattern. Okay, let's just go through it one by one. Sin pattern from error, instant member, null. Long ident. Long ident with dots. Create string will be capitalize the value. Okay, that's my ID. That's 1 out of the 6. The extra ID will be none. The type declaration, none. The argument pattern, it's synargpaths. I don't think I have arguments, so it's just empty. Accessibility will be also none because I don't have any private match expressions. Range 0. Alright, that's my matched value there. The when expression is none. The result expression will be the constant. This is the matched value, and the result expression of the matched value will be just the value itself that I put in the compiled name. So it will be a syn const. It will be a syn expression of the const. Maybe I could just create const. Create const string. Okay, thank you. Which will be the value itself. This is my result expression. The range will be range 0 because we don't care. The SP info will be any one of those. Debug pointer for targets. I have no idea, but it looks okay. Phew, that was quite something. But we get the match value and the results. Let's see how this looks like. Wow. I think we got it here. We got it. We got a match statement from these clauses. Let's and from each enum as well. And that is really, really cool. All right. Let me just paste it in here just to make sure this is like what I wanted to see. Yeah, it works perfect. So next time we have available and then format, we will get this string. Okay, that's really cool. I'm really happy with this. Getting somewhere. We have also the byte array there. What else? What else? And what else we have to do? Yeah, so the next thing, which I don't think we can do this on this stream. The next thing we want to do is be able to resolve things when a property of the schema is an object, right? So let's say nested. This I'm still looking at pet, and I make something nested, and nested will have a type object, right? Type will be object, and the properties will also be something like ID, and ID will have so let's say required, everything that is expected from the schema. Required will be a list of strings, in this case just ID. Properties will be ID, and type is integer. Did Visual Studio Code just figure out what for? Oh, that's cool. Hey. Okay, let's say nested is an object. It has these two. It has an ID and a name. Type will be string. Just string. So how should the program react to encountering a type which is nested? Because the functionality right now, okay, so let's forget about enums for a second. The functionality for now is that we have the top level schema definitions, which are compiled to record types, and for each record we delegate the work to create field type. However, yeah, and field type will just look at the underlying schema, which is like the type and the format, and decide what F# type it should correspond to. However, once it encounters another object, then the type of the field, or at that point, what the program should do, it should create a new type from here, right? Because if you have pet and you have something called nested, let me just generate the code and see and show you what I mean. So in this case, the type will be just a string. So pet has something called nested, and it's resolved to an option of a string, which is incorrect. What I want instead is something just between pet and category called nested. So what I want to do is basically, if you had these two here, if you had these two in here, I want to make type nested equals id int 64, and name will be string option, well, option of string, same thing, option of string, and nested will be in here. So somehow the function create F# field, this function should communicate back to the create record type, the create definitions from here, from create record in schema. Where is this function? Yeah, it should communicate to this function that, okay, now you start making a new type, and then the fields from that type will be encountered in here, if that makes sense. Let me clean things up. Let me clean things up by removing the type from the main and just putting them in here. It became a bit of a mess because of these things in here. Let me just remove them. Okay, we got the enum statuses working. Yeah, this is what I want to do, but basically, yeah, let me remove the find enum type as well. Okay, so that goes here. Because basically I don't want them to be dependent on each other, and I think this works nicely. So we have all just a bunch of functions and we call them from main, right? Alright. It's not defined. Hey, I just did define that, or did I just remove it? Sorry, what happened here? Did I just remove code? Find the enum type. Oh, it's part of this one. This happens when you write code for messed up code for too long. Okay, so there's that. Create record schema. What else? Yeah, now it seems to work. I'll just remove this code from here too. Don't need that. Okay, so we have create record. Nope. Create record from schema. create enum type and create field type. What else? Where is find enum types? Yeah, it's here. So let me put this out of here as well. Let me just put it outside. Okay. Let's also fix this. Nope. Fix the formatting. Alright, so we have all these functions. And I think we have to get into the territory of mutual recursion, where the create record from schema is calling create field type, but field type should also be able to say, hey, I just encountered an object, and the responsibility of creating an object is the create record from schema function. So it should call the create record from schema back, and this is called mutual recursion, where two recursive functions, namely create field type and create record from schema, are both recursive, but they also call each other in a ping-pong fashion, right? I don't want to delve into that today. I've worked with it before with Snowflake, and to be honest, it isn't. It's not something straightforward. I'll have to think about that. For now, I think this is okay, I guess, because okay, I just refactored the stuff. Let me just let's just run it one more time to be sure that it works. All right. Yeah, everything looks good. We also have this format function in here, which is kind of cool. I'm going to have to keep hold of this code for a while, because I need to make it somewhat better with respect to the pattern matching, because this is a bit too much just for this. I think I'll have to think of a nicer way of doing those match clauses, because of look how many things that are not important, but we still have to provide them. The FSAST public API is huge. But hey, we got it. We got there. It's not all too bad. Yeah, it is a lot. Like, yeah, just what I'm saying. So many things, and I don't see exactly where things are optional, where not. But yeah, it's still doable, I guess. So the member format members. Yeah, with this I think I'll wrap it up for today. This was challenging enough of itself, and we got somewhere nice. I think we are almost ready for tackling the paths. Where are the paths? For tackling the paths and creating functions from each path, or from each what do you call it? From each operation ID. Because at the end of the day, I want to create a class that has functions with these names, upload file, and then it will have parameters that use these. I've been playing around with the OpenAPI, both from the Swagger provider and the OpenAPI type provider, and both work really nice with the pet store. So using this schema, they work really nice. But once you give them something more complicated, like the Stripe API schema or the GitHub API schema, they both choke on it. Both, like, Visual Studio wasn't able to even process the project outside of Visual Studio. Just building the project took minutes, literal minutes, which was kind of unfortunate. But that also, like, summarizes my experience with type providers. They all work nicely for a demo. but once you have something real world, they kind of fail on you. They kind of trip and fall. So that's why I'm thinking a lot of building more of these code gen type of solutions, because because you can easily test them against more stuff. You can easily debug the generated code. When working with Snowflake, I got a lot of issues where people have actually stepped into the generated code, which I don't think is possible using the type providers. I'm not sure. It could be, but I think it's a lot more easy to debug the generated code by looking at it and seeing what it's doing and what it's not doing. So yeah, I'm leaning a lot these days towards CodeGen, and OpenAPI was just its turn on the chopping block. All right, with that, that's it for today. Let me know what you thought. Let me know what you want to see next. Maybe I could do a different series, like at the same time, where I do another video of the other series and do this one. One thing I'm thinking about is doing a Fable/Felice interop series. I'm not sure if anyone is interested, but if you are, just let me know. For now, I'm just continuing to work on this and see how this goes. And with that, thanks a lot for watching. Hope to see you next time soon.